Hello, math students. Welcome back to our module on statistics. This is lesson 5, and it is called Mean Absolute Deviation, or MAD. The stands for mean, the A stands for absolute, and the D stands for deviation. Our goal for today we will use the mean absolute deviation to describe the spread of a data set. The question that I want you to think about in this lesson is, how can we represent the spread of a data set with a single number? Okay, before I go into the things to know, I would like you to focus on this title for just a minute. It says the mean absolute deviation. And in the last couple of days, we have been working really hard on learning new terminology that deals with statistics. And one of the things that I want you to notice about this title is we've actually worked with all three of these things. You have been finding the mean with fair share, okay? Then after you found the mean with fair share, then you drew the data on a dot plot. And then from drawing the data on the dot plot, you put a triangle under the mean, and then you drew lines to all the dots comparing them to the mean, which we call deviations. And then at the very end, we talked about absolute, and absolute is the amount of space that you travel from any given number to 0. They incorporate those two straight lines that I showed you in class. So in all honesty, you already have learned all of this. And so this lesson today is just basically a way for us to put all three of those things together. And when you do that, you get the MAD, or the mean absolute deviation. So if we go to our things to know section, you'll start recognizing the vocabulary. So the mean is the average of the data set. Okay, think fair share, or if we want to move away from fair share so you don't have to draw boxes for the rest of your life, the way that you find the mean is you take every point in your data set, add it together, then divide it by the total number of data points, and you get the mean. Okay, absolute value, we just talked about that, is the amount of distance from each data point to the mean, so you're figuring out that distance. And then the deviation tells how far the average of the absolute values are away from the mean. We already know what deviations are, and if you think about that balance point that we worked on in our last lesson, that will help you understand what deviations are. So mathematicians sometimes use tables to help organize their information of absolute deviation. So this is a table that we can use to help guide us through finding the MAD, or the mean absolute deviation. The survey question, or the statistical question, says number of pets. And so basically, we wrote up a survey and we handed it to a group of people and we said, could you please tell us your number of pets? And when we did that, we realized that one person had 3 pets, one person had 2 pets, one person had 3 pets, one person had 5 pets, one person had 5 pets, and one person had 6 pets. We know that that is one person having each because these are what we call their data points. And so on the table, we just listed the data points. You could very easily throw these onto a dot plot if that's something that makes you feel more comfortable and happy. And so if we did that, we would draw a little quick dot plot. Our lowest value that we see on there is a 2, so I'm actually just going to start at 0. And our highest is 6, so I'm going to take that up to 6. So we have 1, 2, 3, 4, 5, 6, and those are our data set numbers that are on our dot plot. And then we're going to look at our data points and put them on there. So I have a 3, so I put 1 dot on 3. I have a 2, so I put 1 dot on 2. I have another 3, so I put another dot on 3. I have a 5, so I put a dot on 5. I have another 5, so I put a dot on 5. And then my last data point is 6, so I put that on my dot plot. So this right here is the visual representation of these data points right here. So then the next step that we did is we need to find the mean. So we talked about when you're finding the mean, you can do it 2 ways. You can do fair share, or you can do the quicker way, and that was take every data point, so 3, 2, 3, 5, 5, and 6, add them all together. So 3 plus 2 is 5, plus 3 is 8, plus 5 is 13, plus 5 is 18, 19, 20, 21, 22, 23, 24. So you get a total of 24. And there are how many data points? 1, 2, 3, 4, 5, 6. So your denominator is 6. So now we have 24 divided by 6. 24 divided by 6 is 4. So we have just figured out that the mean is 4. So we write 4 right here because that's asking for the mean. Once we've found the mean, if we're remembering what we learned in our previous lessons, you're going to put your triangle under the mean, and then next we're figuring out the deviations. So I actually don't have a data point on 4 this time, but I have 2 data points on 3, right? I have 1 data point on 2. I have 2 data points on 5, and I have 1 data point on 6. And so what we do is we figure out the distances. So from 4 to 3, it's 1, right? From 4 to 3, it's 1. From 4 to 2, it's 2. So if you look up here, we have 3 minus 4 is negative 1. 2 minus 4 is negative 2. 3 minus 4 is negative 1, okay? And then on this side, from 4 to 5 is 1. From 4 to 5 is 1. From 4 to 6 is 2. And so we have those as well. And if you look up here, 5 minus 4 is 1, 5 minus 4 is 1, 6 minus 4 is 2. So these are the deviations. So it says right here in the chart, deviations from the mean. We have negative 1, negative 2, negative 3. That's what these are because you're going to the left of the mean. So negative 1, negative 2, negative 3. And then to the right of the mean, you have 1, 1, and 2, 1, 1, and 2. Now we have to take the absolute value of them because remember, we're actually looking for the distance. Deviation means how far away you are. So we're going to take the absolute value of negative 1 and we get 1. The absolute value of negative 2 and we get 2 because negative 1 is 1 hop from 0. Negative 2 is 2 hops from 0. Negative 1 is 1 hop from 0. 1 is 1 hop from 0. 1 is 1 hop from 0, and 2 is 2 hops from 0. So you're just taking the absolute value. And remember, absolute value means the number of hops from 0. So then you have done everything up until here. Because now if we add these two sides together, this would be negative 4, and you take the absolute value of that and you get 4. This is 4, take the absolute value of 4 and you get 4. So now we see that 4 equals 4, so we know our mean is the correct value. So now that we have done that, the last step in finding the mean absolute deviation is that you have to take it one more step. So remember how when we were finding the mean, we added all the data points up and we divided by 6. Well, now what you do to actually complete the steps of mean absolute deviation is you have to take each deviation and you have to add it together. So I have 1 plus 2, that's where I got my 2, plus 1, plus 1, plus 1, plus 2. So I just took these absolute deviations and I'm adding them all together. So 1, 2, 3, 4, 5, 6, 7, 8. So I got 8 is my numerator. And then how many are there? 1, 2, 3, 4, 5, 6. So that's my denominator, just like it was up here. So now I have 8 sixths, and I ask myself, how many times does 6 go into 8 evenly? 1. And then you have 8 minus 6, and you get 2 leftovers, which would mean 2 sixths. But that can simplify to 1 and 1/3. So the MAD is 1 and 1/3. This is the MAD, which remember, MAD stands for mean absolute deviation. And that's how you know what is the mean absolute deviation for this data set. The mean absolute deviation for this data set is 1 1/3. That means that each data point deviates from the mean 1 1/3 times. Okay? So not difficult. The MAD is not difficult. There's nothing difficult about the MAD. It's just a lot of steps. Okay? So first, data points, put them on a dot plot, then find the mean or fair share, then take the deviations from the mean by using your balance points. Once you've found your deviations, you add all those deviations together, divide by the total number that there are, and you get the MAD. Okay, so boys and girls, mean absolute deviation is not difficult. It just has a lot of steps to remember. And that's why we use the table. The table helps you remember all the steps. Data points, then you find the mean, then you find the deviations from the mean, then you take those deviations and find their absolute value. You add them all up, divide by the total number of deviations, and you get the MAD. Okay, so it's really not that difficult. On the back side, we would like to try it again. Oh, this is my math that I showed you from writing it right there. So again, these are the absolute values. 1, 2, plus 1, plus 1, plus 1, plus 2 gives you 8 divided by 6, 1 and 2, 6, which is 1 1/3. So this is just showing you what I did in pen over here. Okay? All right, so now you get to practice. So let me underline your practice part. And I'm actually going to have you do it by yourself. I'll help you get set up, but then I want you to try without me because I truly believe that all of you can do this as long as you remember the steps. Suppose that 7 students polled the following numbers of jokes on April Fool's Day. So April Fool's is coming up really, really soon. 7 kids decided to pull pranks. They probably do jokes. Okay, so it says the following kids polled the following number of jokes. So one person had 1 joke, another person had 1 joke, another person had 1 joke, another person had 2 jokes, another person had 4 jokes, another person had 4 jokes, and the last person had 8 jokes. That guy right there, he's a little trickster, okay, or she. So those are the number of jokes that children did, okay? It says determine the mean and the MAD below. Okay, so the challenge is on. Can you do it? My answer is yes, you can, because I know and believe in you. So this right here is just the student. Boys and girls, do not get fooled by this column, okay? You're actually not doing anything with these numbers. These numbers just identify the student. So actually what I would like you to do is I would just like you to cross this part out because I don't want you to get confused about it. All this is telling you is that student 1 did 1 joke, student 2 did 1 joke, student 3 did 1 joke, student 4 did 2 jokes, student 5 did 4 jokes, student 6 did 4 jokes, and student 7 did 8 jokes. So you really don't need this column, so please cross it out. What you do have to do, though, is you need your data points. So these right here, even though I labeled them jokes, these are your data points. Okay, and if you remember from the other side, it says data point. Okay, so on this side, the jokes are the data points. So what did we do with the data points? Think, fair, share. Okay, think, fair, share, and fair share is the same thing as the mean. So we're looking for the mean. So if you remember how we did that, to find the mean, you take all the data points and add them. So 1 plus 1 plus 1 plus 2 plus 4 plus 4 plus 8. Okay, so remember you add all of those together and you divide them by the data sets. 1, 2, 3, 4, 5, 6, 7. So 7 is your number of data sets. So I would like you to finish that up. And once you do that and finish it all the way that you can, the answer is your mean. Okay, then our next step, if you remembered, you build a dot plot. So our lowest amount, I'm going to go with 0. Our highest amount is 8. So we have 1, oops, why did I write a 1? I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then I put the dots above what they are. So that's a 1, a dot. That's a 1, a dot. That's a 1, a dot. Okay, and then this is at 2. So I have 2 here. Then I have 2 at 4, 4 and 4, and then I have 8 over here. So there's your dot plot. Once you figure out your mean, don't forget, put your triangle wherever your mean is, draw your line so you can see what your deviations are. Your deviations go in this box. Remember, once you find your deviations, then you have to take the absolute value. Remember, the absolute value is these 2 bars. So the deviation would go inside, and then what does it equal? And you put your answer here. It goes inside these 2 bars, and what does it equal? It goes inside these 2 bars, and what does it equal? It goes inside these 2 bars, and what does it equal? It goes inside these two bars, and what does it equal? It goes inside these two bars, what does it equal? It goes inside these two bars, and what does it equal? Remember, absolute value is the distance the number inside is from 0, so don't forget that part, okay? Then, just a quick reminder, to find the absolute deviation, it's just like finding the mean, except for you use these values. Remember, the answers that you have here, they get added on the top, divided by how many you have, 1, 2, 3, 4, 5, 6, 7. So again, I'll set it up for you. So you're going to take the first one plus the second one plus, so 1, 2, 3, 4, 5, 6, 7. And there are 7 data points, and you're going to divide by 7. When you get your answer, that answer is your MAD. Okay? So that's all I'm going to help you with. I want you to finish it by yourself, and when I check your notes for the TLC, that's what I'm looking for. Okay? So MAD, it's not difficult. It's just long. And because it's so long, it can make you go mad. Ha ha ha. Get it? Okay. So back to our goal. Today we will use the mean absolute deviation, MAD, to describe the spread of a data set. The question that I want you to think about is, how can we represent the spread of a data set with a single number? The answer to that question is because we have the MAD. So how can you represent the spread of a data set with a single number? Because the MAD is the data set spread. Okay, so that's why, because we have the MAD. All right, kiddos, that's all I have for you in this lesson. I'll talk to you soon. Bye.